And welcome back to the Turdberg Show. All right, today's video is on finding the enthalpy of an equation. Now, this looks like it'd be a really hard problem. And if you didn't know what you're doing, it would be kind of a hard problem. But it's really not that bad. We're going to break this down to 3 steps. So first off, you should be like, Mr. Cole, how do you know it's going to be the 3-step problem? Look at it. It gave you this equation, but out on the end, it didn't finish the equation. It didn't say positive 13 or 12 or 52. It just says nothing. So what we've got to try and do is figure out literally what is delta H in this problem. All right, it's going to be an easy problem. 3 steps to it. Step number 1, convert to moles. But now, right off the bat, when you look at this, when you read the problem, you can see 2 things in here. It's got 50 grams of water, and 1 gram of potassium chlorate. So the most common screw up people make on this is they don't know which one to pick to do the converting to moles. Well, let me make this really simple. And this is even if you were in college. Never the water. This first step will never, not in any normal class, will never be about the water. So now, which one of these 2 are we going to convert to moles? The 50 grams of water or the 1 gram of KClO3? I choose B. So let's do this. Let's start with 1 gram of KClO3. And step number 1, we're going to convert to moles. Well, I'm going to have a mass for that first. So let's see, where's my calculator at? 39 plus 35 plus 48 for 16 times 3 means that's 122. At least I hope I'm doing that kind of quick. So there's 122 grams of KClO3 in 1 mole of KClO3. Now I'll put my equal sign down, and I'll go ahead and do that one. 1 divided by 122, and it's going to come out like 10 to the negative. So I'm just going to round off 8.2 times 10 to the negative 3. So let's write that down. 8.2 times 10 to the negative 3 moles of KClO3. All right, well, step number 1 was very easy. So on this 20-point problem, or at least I'd call it a 20-point problem, we've already knocked out a good little bit of it. So what is step number 2 then, is what we should be next. So step number 2 is going to be Q equals, I do not want to change my color scheme, you crazy thing. Step number 2 is going to be nothing but MC delta T. And how about this? I'll put this in green here. Pick water. Step number 2 is always about the water. So step number 1, we will never use the water. Step number 2, we will always pick the water. And yes, if you write this down, you can use it when you take your test. So Q equals MC delta T. Q equals. So let's go back up and look at the problem. What's M for water? Well, it says 50. Good, nice, easy number. So there's 50 grams of water. Now you do have to remember something. What is C for water? 4. Oh, you're correct, sir. And no, I'm not talking to myself, or maybe I am. There could be voices in my head. What do you know? You're watching this TV. There. Actually, you're probably not on TV. Anyway, hey, let's go back to this problem. Anyway, the last part of this problem is delta T. Now, I'm going to do something. I'm just going to do this. Delta T means the final temperature minus the initial. And so I'm going to go up here and look. What was my final? It gave me 2 temperatures. So it gave me 25.0 and 24.39. Now, here's the thing. Even if I do this backwards, I can't lose but like a point in this problem. So it's not the end of the world. But hey, I don't want to lose a point. Which one of these 2 was the final? 25 or 24.39? 24.39. Very good. So it cooled off to 24.39 minus 25. And I'll show you how I do this. I just put this in my calculator all at once. So when I do this, I'm just going to go 50 times 4.186 times, and what I'll do is just put this in parentheses, the whole 24.39 minus 25, which is 0.61 or negative 0.61. But anyway, hey, why show off now? Now check this out. My answer for Q comes out negative 127 point, and I should have rounded off. Matter of fact, I am. Let's just round off that number. Negative 127.6. Let's round it. What's it going to be? Negative 128 joules. We'll leave it at that. Now, here's the thing. This problem didn't ask you to find Q. It asked you to find delta H. Now, you're probably looking at this going, well, doesn't delta H stand for heat? No. Q stands for heat. Delta H stands for heat in a reaction. That's why it's got this sexy name called enthalpy. They're basically the same thing. But here's the difference. Bam. Q of negative 128. Remember, that Q is for the water. That means the water lost 128 joules. Let's use a little sense. If the water lost 128, the chemicals in the problem must have gained. So instead of negative 128, I'm going to write positive 128. Meaning at this point, you should be able to tell me endo or exo. Well, if delta H is positive, that means this is a, and I don't have to write this down. I'm just doing this because I like to show off, I guess. This is an endothermic reaction. But now, if you remember, I kept saying there's 3 steps in this problem. Step number 1, convert to moles. Step number 2, pick water, MC delta T. So what is step number 3? Well, I'll give you a hint. We need to do something with these 2 numbers. We could multiply. No, that don't make sense. All I'm going to do is this. I'm going to divide by my moles. 8.2. And if you're getting mad at me because I didn't write like a formal step 3, here you go. Step number 3. Just divide your answer by that mole. Because here's the thing. You found delta H for this tiny little 82 10,000ths of a mole. I want to know what this is for a whole mole. So I'm just going to divide this by the moles now. And again, I need a calculator for that. So 128 divided by 8.2, 10 to the negative 3, and there's my answer. Now I want you to look at what I'm going to write down. Don't shoot the messenger now. I know you're thinking, no, we got so many things we got to do. If you look up here in this problem, and I thought I could write on that. Oh, I can. Instead, I accidentally made kind of a mess over it. Oh, I thought I could write on that. Maybe I can't. There, good. It's just a little laggy. Here. That is my answer, but the thing is, the problem will want the answer in kilojoules. So all I have to do, I'm not going to write, here, I will. I'll write it down. I'm crazy. 15,000. That's not 15,000. 15,609 joules. I got to put the positive, though. But that is not what you would ever see in the textbook. These problems are always in kilojoules, which means my real deal, and I am finally finished with you answer, is 15.6 kilojoules, and I am done. 20-something points of masterpiece here. Step number 1, convert to moles. Step number 2, MC delta T, divide. You got to change this to kilojoules. But anyway, that is how you find enthalpy in one of these problems. Anyway, thank you for watching the Turtberg Show, and as always, I love hot wings. Bye.